Alright, today we're going to do Unit 6, Chemical Reactions, Part 3. This video covers predicting products for synthesis reactions, predicting products for decomposition reactions, and make sure that you grab your reference table for today. I'm going to give you a minute to do that. Alright, so now that you have your reference table, let's go ahead and start talking about our different types of chemical reactions. So today we will be learning how to predict products. In order to do this, you need to have your reference table because all the answers that you need are going to be in your reference table. Alright, so we've already talked about what a synthesis reaction is. Remember that your synthesis reaction is where you have two or more reactants combined to form only one product. So when you are looking at the general equation here, take notice how you have a plus sign here on your reactant side, which means you have two reactants. They are going to combine together and yield or produce one product. I know that this is one product because I have no plus signs on my product side. Here is an example of what a synthesis reaction could look like. Notice how we have magnesium plus oxygen as our two reactants. They form or produce one product. In this case, we are making magnesium oxide. Your metals will react with oxygen to form metal oxides, but there are a couple of exceptions to this rule, as you know there always are in chemistry. These exceptions are silver, platinum, and gold. Alright, so now we're going to take a look at your chemical reactions, especially synthesis, in your reference table. Go ahead and have your reference table out and turn to page 6. You will find three types of synthesis reactions in your reference table, and I'm going to show you where they are on the next slide. You need to be able to identify the type of reaction based on the formulas present in your chemical equation, and I'm going to show you how to do that. Alright, so here is your reference table. This is page 6. Alright, we have solubility rules at the top. And then we have guidelines for predicting products of selected types of chemical reactions. And then the very first type is the synthesis reaction, which we're going to look at right now. Notice how you have a key up here. Wherever you see a capital M, that is a metal on the left-hand side of the periodic table. Wherever you see NM, that represents non-metals, which can be found on the right-hand side of your periodic table. Alright, I'm going to zoom in closer onto synthesis. We have 3 different types of synthesis reactions. The first type is a 1A synthesis reaction. This is the formation of a binary compound. Remember this word binary? It means two. So if we have a binary compound, that means we have two elements combined together to form one product. Your product will only be two elements. Hence the name, it is binary. A 1B synthesis reaction is when we're going to have a metal oxide plus water. So here is our general equation where the M is metal, the O is oxygen, so this is our metal oxide. We add it with water and it will produce a base. A base is any chemical that has hydroxide on the end. A 1C synthesis reaction is a non-metal oxide plus water reaction. Here's the general equation for it. Here we have NM, that's your non-metal, and your oxygen, plus water is going to produce an acid. Remember, with your acids, hydrogen appears in the front of your chemical formula. Alright, so let's practice a couple of these. We're going to predict the product for this chemical equation. The very first thing that I want you to do is I want you to look in your reference table to determine what type of chemical equation this is. Alright, I've looked through here and I see sulfur. Sulfur is a non-metal. Sulfur is paired with oxygen, and we are adding water. Alright, so if I'm looking at my reference table, This is a non-metal oxide and water synthesis reaction, which is a 1C. Okay. With this product that we are going to be producing, we're going to be making an acid. All right, so with an acid, we're going to have hydrogen in the front. All right, and then we're going to kind of combine the rest of our elements together to create a polyatomic ion. Here I have sulfur, and I have 2 oxygens here and another oxygen here to combine to make 3 oxygens. So that is SO3. All right. And I need to check the charges on these compounds to make sure they balance out to equal 0. Remember that hydrogen is a non-metal on the metal side, so sometimes it pretends to be a metal. In this case, it has a positive 1 charge. And then we have SO3. SO3 is sulfite, and it has a negative 2 charge. These charges do not balance out to equal 0. We do need 2 hydrogens here to balance it out. So your chemical formula for the acid will be H2 excuse my handwriting here, SO3. Okay? Here's another one. Here we have SO2. The first thing we're going to do is we're going to decide what type of chemical equation this is. I'm looking at my synthesis reactions in my reference table, and I see that I have 2 elements here. I have sulfur and I have oxygen. So I will be creating a binary compound. This is a 1A. Now, since we have 2 nonmetals coming together to form a covalent compound, we do not need to check their charges. We're going to combine these 2 elements together to form a binary compound of sulfur dioxide. All right, we're going to do a couple more together, and then we'll let you do some on your own. Here I have aluminum oxide plus water. First thing I'm going to do is I'm going to look in my reference table, and I'm going to determine what type of synthesis reaction this is. This is a metal, since I have aluminum, a metal oxide plus water chemical reaction. And this is going to be a 1B. Now our 1B chemical reaction is going to produce a base. Remember I said that bases have hydroxide in them at the end of your chemical formula. So here's hydroxide. All right, and I'm going to pair it with my metal, which is aluminum. Okay, now since this is an ionic bond, we have a metal and a polyatomic ion, I do have to check their charges to make sure they balance out to equal 0. Aluminum has a +3 charge and hydroxide has a -1. They do not balance out, so I'm going to have 3 hydroxides. So my overall formula then for aluminum hydroxide is AlOH3. Looks like this. Okay. Here are a couple of others that you can try on your own. First thing I would do is I would decide what type of chemical equation they are, and then you can predict their products from there.